we're going to start with some very basics in the important concept of solving word problems and applications, as we're going to see those repeatedly throughout the year. So we're going to develop a basic problem-solving plan that we're going to be able to use for just about anything application word problem we look at this year. The most important part of this is understanding that there are verbal phrases and different words that in algebra mean certain things. It might be different than you use them in everyday language, but we're going to try to highlight some of the key words here. If we look at verbal phrases that imply addition, we have the word sum, or the phrase sum of, 8 more than, a number plus, kind of a basic one there, number increased by. Those are 4 verbal phrases that imply addition. What this one here, the sum of 6 and a number, would be 6 plus x. 8 more than a number, we would start with that number and we would add 8 to it. 8 more than it. We'd have a number plus 5, that'd be x plus 5. And a number increased by 7 would again be x plus 7. So those all are addition. That's the little phrase expression there, how it would be written when we translate it into an algebraic expression. A couple of things here with subtraction. The first is the order is important in subtraction because 3 minus 4 is not the same as 4 minus 3. So that's very important here. But let's highlight the subtraction words or phrases here. Difference of implies subtraction. Less than implies subtraction here. Minus, again, another basic one. And a number decreased by. Okay. Again, those are the basic words. And then there are more words that I'm sure we'll come across this year. These are the most common ones that we will see. The difference of 5 and a number is 5 minus x. This next one, 4 less than a number, is your number minus 4. If we think of this one up here, if we have 10 minus 4 and 4 minus 10. This is why order is important. We want 4 less than a number. So here our number is 10. Our number 10, 4 less than that is 6. Okay, 10 minus 4 is 6. Well, 4 minus 10 is negative 6. And those are not the same. So that's why this is the one we'll be looking at there. 7 minus a number is pretty basic. 7 minus x. And a number decreased by 9 is x minus 9. Kind of like that second bullet there. The same goes there. Some verbal phrases here that imply multiplication and division. Again, let's highlight these words. Product is multiplication. Times implies multiplication. Obviously, the word multiplied will imply multiplication as well. If we look at division here, the quotient of, that implies division. And obviously, the word divided by, the phrase divided by would imply division. Okay. If you look at multiplication, the product of 9 and a number, that's 9x. That means 9 times x. 10 times a number, that would be 10x. And a number multiplied by 3, x times 3. Now, these, we could flip-flop the order because the order you multiply 2 numbers together doesn't matter. It is very important in division, though. If you look at the quotient of a number and 4, that's x over 4. X over 4. 7 divided by a number, that's 7 over x. See the difference in where that variable is? Those are, again, if we were to think of x as 12 here, if we did 12 over 4, that's equal to 3. 4 over 12, that's only 1/3. So those are different. That's why the order and division is important. What's on top, what's on the bottom of the fraction bar there is very, very important. Again, we touched on the fact that order is very important there. This other one here, the word per, typically implies multiplication times the variable. So if you're at $8 per shirt, it would be 8 times X, 8 times that variable. And we're going to see that in our examples here coming up next. Here's our process. Identify what you are trying to find. Okay? This is in the question. Okay? That's in the question. Define your variable. This represents what you are trying to find. So it corresponds with that first step. Okay? Once we have defined the variable, we'll write the algebraic model and then solve. At this point, what we know about solving equations, we're worried about setting this up. We'll get into solving here in the coming weeks. But first 3 steps are very, very important. First example. You and 3 friends are having lunch at a Chinese restaurant that charges $2 per plate. Your bill is $25.20, which includes $1.20 in tax. Write an equation and solve to determine the number of plates you and your friends purchased. So we are looking to find the number of plates purchased. Okay? So from there, we let X equal the number of plates purchased. Okay? The number of plates purchased. From here, we go to write this equation. Okay? This word per, $2 per plate. Well, X represents the number of plates. So I'm going to have 2X. This is the amount spent on food. In addition to what we spend on food, we have to spend $1.20 on tax. So we add 1.20. Okay, this is the tax. And then we also, we add those two together, our total bill is $25.20. So this is our algebraic model, our equation, that we can use to solve eventually, in the next week or so. Solve that to find out how many plates you and your friends purchased at the Chinese restaurant. One more example here. Go ahead and give it a shot. I'm going to pause for a second, and then I'll put the solution up. Very similar to the last one. We're asked to find the number of albums that you and your friends purchased. So that lets us let X equal the number of albums purchased. Okay, it's $6 per album. So that'll be our 6X plus our tax, $5.76. That'll get us our total of $77.76. Again, that's the model we were looking for.